This is IBM Museum. It's raining outside, but I have to make a video. So about a week ago, I had someone that had a Mall 25 that he couldn't get it running. It didn't display anything on the screen. And so as a last resort, he went through sending just the planar to me for me to go through and troubleshoot and to get him a working planar in return that he could put in his system. And so the planar he sent is just, he didn't even have the sims on it. Of course, I've gone through and I've mounted it in the system. This is what they call the Type 2 planar that IBM released later after it fixed some issues with the first planar that was released called the Type 1 for this Mall 25. Now, the Type 1 is, the difference between the Type 1 and Type 2 is just this power connection is more outboard on the Type 1. Very little components are changed around otherwise. And then there's also the MCGA video had a gate array chip that could produce some errors that IBM went through and replaced. There's been videos online of that process and the EC that happened for that engineering change that IBM released for that. Since this is the all-in-one unit, it does have the video connection that's feeding into the monitor. I went through and I just pulled down the tray like this. I mounted it in there just with one screw. And of course, I went through and I connected up my parallel port postcode reader. And I highly recommend these just as an idea of whether the system is operating or not when you don't have any video. Every PS2 model has a parallel port and supports having a parallel port postcode reader on it for troubleshooting. Now this has 4 digits, and typically it's just where the 2 digits of this current code is the thing to worry about. And I do have it powered from this mouse adapter plugged in here. When I would go through and start the system up, it would halt at the code 01. And that's helpful enough as it is, because it told me that the CPU has some functionality. I mean, it's going through and it's writing that first postcode to there and then halting. But I did go through and swapped out the CPU for the first troubleshooting step. And that didn't improve things. It still halted on that postcode 01. So what I did next is I was going to work through the BIOS chips. There's 2 of these one-time programmable, or called OTP EPROMs here that contain the BIOS. And IBM actually had only one BIOS version for the Mall 25, but they did label the chips differently, and they tried to have where one particular FRU that was on a chip on the Type 1 planar, and the FRUs are identified here on the Type 2 planar. So I went through and I replaced the U17 first, which is this chip. And as soon as I swapped in the chip from a known working board, the system powered up. It went through and did memory checks and everything else. So ultimately, it was where this chip has some bit rot or something has changed on it. So I went through and I copied it onto my with my EPROM programmer and put it up online. And just a little bit ago, I actually pulled down the file and compared it to the known good example. I do have my my tweener system out with the EPROM reader, have that chip loaded up, and since I have the DOS on there, I went through and did a file compare on a binary level. And I saw something enough to where I'm going to actually go through and I'm going to read the EPROM again on video and kind of go through the sequence of the file comparison and just to show what it looks like is going on. I'll go through and I can get switched over to the tweener screen, and that will be this. Okay. And okay. So let me get the keyboard down. And this is where I went through and I'll go through and I can put the file up, the second read version. I mean, I'll have a local copy and it should be the same as what I want to do to, I've got the file already on the system too that I want to compare it to. But in the EPROM programmer, and I have it up here, I have it set to the correct chip type. And I've gone through and of course unchecked for the pin detect and check ID. We can just go through and read this. Okay, read finished. So some of the text here, I mean, this looks fine in some areas where the in particular the copyright IBM Corp 1981, 1987. I mean, that all looks pretty good. And of course, a lot of it being the code otherwise. There might be some strings in here or something else. But I mean, to the just looking at things, you really can't see, you know, what might be bad, effectively bad there. Let's go through and I'm going to save this. And actually, let's step up a level. Yeah, let's step to this. And I'm going to do this as a second read. Okay, so it's saved that file away. And we'll go through, we'll actually close out of the EPROM reader program, and I've already got these other files, and this is the image that of the chip as it normally should have it. This 00F2122.bin. And the first read I did of the chip, I've got that as that 25 bad u17.bin. And within this directory, of course, I go through and I've identified the all the just a kind of note on this on the BIOS version for the MUL25. And I'll give a link to this in the video description. It's also where Major Tom does have this information up on the Ardent tool, of course. And this is the MUL25 page. I'll also provide a link to that in the video description. And just going through, it gives information about the planar, and it shows that layout, that U17. And it looks like this page does still need a little bit of work with the way it is. It still is not labeled the best. And I think we just have a diagram of the type 2 planar. It does identify, and it has my photos here of the type 1, type 2, so people can go through and check those out a little bit. And it does have the somewhere in here it does have the talk of the BIOS of how they're split between the type 1 and the type 2. And it's the same BIOS effectively, just they're effectively marked externally. And IBM did that. I mean, the notion was that that would be the way to tell the difference between a type 1 and type 2. And they just didn't follow through. It seems like most of the time if you encounter the type 1s are kind of rare to find out there. But when you do, you typically find that earlier or that FRU marked as for the type 1, and all the type 2s out there, you're going to find this other version of the BIOS, or that marked with that different FRU. So let's go through, and I guess I could have gone through. I wanted to, and I'll go through, and I can actually pause for that because I'm going to go through we can go through and we can move that second read file over to the directory. I can show that. We'll do a restart. With that process, I'll have to see if I'll pause or not. For the okay, for the downloads, or excuse me, we want to go into the directory structure of the system. Okay, and into my EPROMs, 8525. There's my second read. I'm going to go through and I'm going to copy it. We're going to go over to my C drive that has the DOS on it. And in here I've got a compare directory. I've got both those files. I want to do a file compare, and I'm going to add the second read. Okay, those are all 32 KB files from that EPROM size. And let's go through and restart the system. I have that nice creature speaker system connected here. Okay. Okay. And this boot process, as I say, it can be just a little bit, takes a little bit of its time. We're still doing pretty good here. We're below 10 minutes of video. I think I can go pretty short here and still explain what I'm doing. Okay, I'm going to pause till the menu comes up. Okay, at my dual boot at startup, I'm going to select the MS-DOS. Okay, and so we're going to change directory to that compare, and this is what the contents we have of that. I have my DOS directory in the path, so it's going to find the file compare program, and that's normally the FC, standing for file compare. The first thing I want to do is I want to find out my second read. So I do a file compare /B for binary, and that does a binary comparison. So all the bits of the characters, and we're going to go through, and our first file and of course the full file name here to our second read. Make sure I get that file name in there correctly. And I'm just doing between the first read and the second read. I want to make sure that that is, and I'm going to do a more pipe just in case there's more information than on the screen. All those files are otherwise the same length and otherwise. And so there's no differences. So that's a good thing. That means my EPROM reader between the first and second time I did a good read both times. And so we're going to go through, we'll run the file comparison again, /B for binary. We're going to do our 25 bad u17.bin, and that's of course the first file, and then it's compared to our known good image of 00F2122.bin, and we're going to do a more. Okay. So as we go through, and right immediately from the start of the contents, we are seeing these indications of 4.6 being in our first file, the content of that first byte, and 6.6 being in our reference file. Going on to the sixth byte, we have 4.3 in our EPROM that we're trying to verify, and it's 6.3 against that reference, the known good reference EPROM. And then it pretty much goes, it looks like just about every character in there. There's a few selections, and that looks like probably skips. That may be where the there's that contents are 0 or something else for that byte. But as we look through this, we see that the difference between, you know, there's a, and of course this is hexadecimal, but that first character, you know, is a 4 on the one file, and it's a 6 on the other, or it's a 5 on the first file and a 7 on the second one. There's a difference of effectively 20 as it's shown here, and that ultimately means, of course, with the binary storage, that there's a single bit difference between the two files for all the characters that have any value in them. It's going through, and this is where, like, one of the data lines on the EPROM is broken effectively for here, because it's not reading that value correctly that's burned into the image. And so you know, just about the whole EPROM as it is corrupted. And I mean, I'll even have to go through and control break, but you just see the hexadecimal differences between those byte locations at every point here. I mean, even at the bottom there, of that hex 94 byte of 00 in the bad BIOS, and being 20 on the good EPROM. So that shows just where that bit effectively is misconnected within the chip. just that chip is degraded somehow that has made it go through and report things like that. And that's true for just every level in here, that there's a matter of 20 hex difference between the two files. Okay, so we're going to do a control break just to get out of that. Actually, that. Okay. So, you know, that shows that EPROM is bad. And I did have a planar that was also sent to me. I want to go through and let's get up the camcorder again. Okay. And I went through and I actually pulled both. I mean, the system ran good when that other EPROM was pulled off of the system, and so I'm thinking that the contents of this are still showing correctly. But as I say, and I'd have to look at even the pinout for the this EPROM to find out what the particular data line is of one of these pins, basically having a break on it to be like that. And I've gone through. I've got good EPROM chips in there now for this. I'm actually going to go through and I'm going to send a different planar that I know is good, just in case that this planar has other issues. But it looks like, as I go through and test it, it looks like it fires up. Of course, I've got this face down. It does otherwise come up with, it's got a novel network client on it, on the hard drive that it boots from. And so it does have errors, but that's the operating system is running fine. So I dug around for the planar that I received a few months ago. It was in the same sort of arrangement, that the person that had it could not get their mul 25 to run, so they mailed the planar, and I actually immediately mailed the planar back to them. I set that aside, and I just saw it the other day, and I can't lay my hands on it today, but I want to see if it's the same relative error. I want to go through and try and read the EPROM chips once I find that planar, just to go through and do the comparison. And there's a possibility I can go through and give an update, because if that's happening, it's where, you know, that maybe would be something, an idea for the first thing to look at with for a problem. And, you know, I do have the files for making your own. If you have an EPROM burner, I mean, you can order those 27C to 56 chips and you know, put an image on an EPROM that you create, just to make sure that of that as well. If you're encountering that, or to solve from a distance, you're always welcome to contact me and find out if I'll help. And then, of course, if you're going to do the troubleshooting yourself, get one of these parallel port postcode readers, because as it shows, that if this BIOS is kind of mixed up, this should just go through and read that 01 and not continue any further. It hangs at that postcode. So I want to go through and I'll bring down, since there's photos of this. We don't have a good diagram of it though. I do want to bring out, this is the type 1 planar. And I don't have a CPU in it right now, but it's very easy to see. It's a very similar layout. Of course, the MCGA gate array chip. And I'd almost be better looking at I recognize it more on the Type 2 board for what it's been replaced with. Okay. The 83 or okay. So I believe that on the Type 2, this is the microchannel. I mean, excuse me, the MCGA gate array chip, and I think it's the same layout here to where okay. So this is the MCGA gate array chip that was replaced with the different version for the Type 2. And of course, on both of these, you can't really see over on this edge. It does have the ceramic RAM DAC chip, just like the Type 1 does. And normally IBM, when they initially release a planar, they'll go through and the RAM DAC, and that just converts it over to an analog signal for your video, as MCGA and VGA does. And then later on in the design, they went through and they replaced that with a plastic RAM DAC. But the EPROMs on this, you know, they're labeled a little bit different externally. This actually looks like someone made. I mean, these are not one-time programmable. They're with labels and things like that. It does have an official-looking type on there, so that looks like IBM did these. But that's what it was, is they went through, they had EPROMs on there for this Type 1, and then later on, they went through on this board and made them the one-time programmable, or selected the one-time programmable chips to be on there. So, as a last thing, let's kind of zoom back out. I'm going to just reach down underneath, and we'll see how well this shows up with the ring light. But I'm going to go through and I'm going to flip the power, and we can see that postcode on the parallel port go through, and instantly it goes through and it starts going through numbers. Didn't just halt at the 0-1 like it did before. We can hear the hard drive spin up. We know that things seem like they're operating. I mean, the fan on the power supply up here is operating. We heard a beep. We're hearing read access from the hard drive, and so we know that this unit is running, or at least it's getting up through the postcodes, and the last code showing there, and I'll have to block some of the light there without blocking the camera, but it's actually saying FF, and that's effectively that it's complete. That's the highest hexadecimal number that can be represented there. So this system, this planar, is now functional just for swapping that BIOS chip. And that's a troubleshooting process. Normally you want to have a part that you can easily swap in there, the equivalent part, to be able to check things, a different CPU, a different BIOS, just to kind of go through with a minimal system to see if you can identify what the issue is with that with the part you're testing. So if you enjoyed this video, click on that like button, please, and subscribe to my channel if you have not done so already. Recommend it to your friends. I would love to have more subscribers. I'm still gaining them ones and twos every day, but I'd love to be at the point where I finally go over at least 1,000 subscribers so I can start making YouTube announcements. But that's all I have for now. This is IBM Museum. Thank you.